Good morning, everybody. Welcome to today's webinar. We have John Peters here today, who will be presenting the webinar on clean sample introduction accessories for spectroscopy. Before I hand it over to John, I'd just like to say that you can ask questions at any point in time during the webinar by posting them on the question option. It should be located on your dashboard, the webinar dashboard. You can also post anything through chat directly to John or to myself. And we will be recording this webinar and have it available on our website early next week, along with the slides that John is presenting. Okay, John, I'd like to hand it over to you.
Hi, Betsy. Thank you. Hi, everyone. Good morning. Good afternoon. I would like to discuss today a few things related to some clean sample introduction accessories that CETAC offers for the spectroscopy market. I did want to mention that I will give a presentation for approximately 30 minutes, and then we'll do a question and answer session at the end, as Betsy mentioned. So what we will cover today are some of the accessories that CETAC manufactures and how they can improve detection limits, how they can reduce interferences, reduce carryover problems, and also protect your samples from contamination, these being very valuable, of course, to the lab. The technology categories that I will discuss include the autosampler design improvements that we've made in recent years, as well as the dual rinse accessory that we offer, the sample avoidance and drip-free technology that we've released recently, and enclosure designs, the entire enclosure family of models that we've come out with recently, some of which have been in the last couple of months, so new technology for us. So just for some background, some contamination sources. Where do they come from? There are a couple of different sources, of course. One is the sample itself, contaminated with additional problematic elements or matrix contaminants that cause difficulties in the analysis. Others would be in the sample pre-treatment or digestion preparation stages before it gets to sample introduction. And the third would be during the sample introduction itself, either the person manually injecting the sample into the ICP or other instrument, or the technology that's used to do that sample introduction itself. So that will be the main focus of what I will discuss today. In terms of how to eliminate some of these, the sample preparation and environment that this technique happens in can be improved. This can be done either through a laminar flow hood or by improving technique, of course, and also with other accessories such as the sample dilution accessory that we have, the SDX, and the AS Express, the rapid sample introduction accessory. We are going to do a couple of webinars. This one will focus on the contamination sources and how to eliminate them with our accessories, but we'll do another one that will help eliminate interference issues. So, for example, at the top of the slide says sample can sometimes be contaminated, and that creates interferences within the instrument itself. We do offer a variety of techniques and technologies to combat this in terms of interference problems. So that will come in a pending webinar that we'll announce very soon. So just to cover the first topic, improvements that we've made to the autosampler itself are mainly about the hardware that has changed. So rather than having metal components in the cover, in the base, and other moving parts, we've changed out most of the materials with ones that do not rust or fall apart with exposure to strong acids. And then for a variety of reasons. One is the autosampler lasts longer. It's capable of holding up much better in a robust manner and remaining reliable for long periods of time. But also the corrosion has the potential then of contaminating the samples that are in proximity to it. So we've changed the carbon fiber arms on the Y and Z axis. It used to be a different material. Now we have polypropylene for the cover and the rinse tray. So everything coming in contact and hovering over the samples is either plastic or carbon fiber. So we also have polybutylene tetraphthalate and polyethylene terephthalate for the sliders on the Z and Y directions. So these are all strong, lightweight, chemical resistant materials that will hold up very well to both strong acids and oils and even chromatography solvents like methanol. Other improvements include the electronics that have been implemented with the new autosampler line. So this would be the 560, the 280, and the 860 that have replaced the ASX 520 and ASX 260 and Accelerate. So the new electronics have a variety of new features. Mostly the movement profile now is much more smooth and graceful. That creates possibility for much more accuracy. It also has an anti-backlash movement, which causes it to move to a particular location from the same direction every time. And what that does is eliminate any error that might be in the gears of the motion so that it's able to have a much higher accuracy level. But also, new improvements to this would include the sample avoidance technology that we've implemented recently. So I'll go into more detail about that shortly. Another improvement that we have is a dual rinse option. So this is for problem carryover applications where you might have sticky elements, a mixture in the sample matrix that might include some homogenized system or an emulsification with an organic material or fat. But also for regular applications where carryover is very important. So there are a couple of different ways that this can be configured. One is to have two different rinse solutions going to the rinse stations 1 and 2. So this would be gravity drained then out to a waste container from each. And best for applications where you could, for example, put a little bit of organic material into one of the rinse stations to get rid of fats and other contaminants from that type of matrix, or have a little bit of HCl to get the carryover down that way. For mercury applications where the carryover of mercury is important, you could add 200 parts per billion gold, for example, to one of the rinse solutions so that the mercury is then pulled out. So there are a couple ways to acquire one of these. One is through an upgrade kit, so anybody that has a ASX 560 or 280 autosampler can purchase a spare part and upgrade. It includes the rinse station and then all the tubing that is required to install it, and as well as an instruction manual. The second way that it can be configured with the dual rinse is with active draining. And the way this works is on the peristaltic pump itself, there are two different size pump tubing, one larger than the other. So the waste out is being pulled from the rinse station faster than it's being fed into the rinse station. So this still reduces carryover. It just creates a clean rinse station and then a dirty one afterwards. So the gravity drain then is unnecessary. This is best for applications where not having to deal with gravity draining out of the rinse station is important. For example, space limitations where your waste container might be vertically situated to where gravity draining doesn't work, or just general applications where the same rinse solution is acceptable for reducing carryover and you just want two different rinse stations to do it. So the way this is configured is very simple. That's the other advantage of this. Because it's an upgrade kit, it will fit on any ASX 560 or 280. The software that's included with that auto sampler has a package called the dashboard, and within that is an auto sampler config applet, and in that the dual rinse feature can be enabled simply by hitting a checkbox. And then it's configured with a slider simply by selecting how much time it spends in each of the two rinse stations. So the OEM software or whatever software the auto sampler is connected to does not need to know that the dual rinse option is even installed. It's all happening in the firmware of the auto sampler itself. So for example, if dual rinse is selected within this configuration and the OEM software tells the auto sampler to go to the rinse for 60 seconds, and within our auto sampler config software package, it's configured to go to rinse 1 for 15 seconds. The result will be it will automatically go to the first rinse station for 15 seconds and then spend the remainder of the 60 seconds in rinse 2. So it's a sum of the total and the amount of time it spends in each one is configured in our software. So here I have a video of the rinse station in action. It may be difficult to see if there's buffering issues, but I'll explain what's happening in case it is jumpy on your screen. This is configured in the way with the active drain so that the material being pulled out from the top two tubes is being pulled out at a faster rate than what's being fed into the bottom two. So you can see it's just in a loop here where it's being fed into the two rinse stations from the bottom through a split and then pulled out at a faster rate through the top and then up so that gravity draining is not required. So third category that I wanted to discuss is the drip avoidance technology that we've introduced recently. A couple of these would be the new tubing solution. We have a chemical resistant Tygon now installed on all of the auto samplers that we ship. And this change happened in February. It resulted in some observations that we received from customers saying that the Tygon they were receiving was falling apart, and it was causing the probe to retain an oily contamination, which caused the surface tension on the Teflon to change, and therefore water to stick to it or acid to stick to it, and therefore fall off while it's moving, causing contamination. So what we did was test a variety of different Tygons and came up with a formulation that works best for this application. So it holds up very well to acid environments and does not contribute this oily contamination that was responsible for a lot of the dripping problems that some customers had, particularly when using particular types of sample matrices. So the advantages of this include reducing the potential for liquid to drop off of the probe or to form on the probe in the first place. It reduces also the amount of leaching of inorganic materials from the tubing itself. So when soaked in an acid environment, the new tubing produces a lot less carryover problems and inorganic contamination at the very low level. So this is ideal for mass spec applications where very low detection limits are important. It also holds up better to acid environments. It is recommended to change the tubing every 6 months anyway, but the new tubing is backward compatible with existing auto samplers as well. So the new catalogs for the ASX 560 and the ASX 280 have the updated tubing solutions, and then all of the tubing kits that go out with auto samplers currently are equipped with the new tubing, the chemical resistant tubing. But if there's a customer that has a 520 or a 260 that is having problems, the recommendation is to buy the new tubing kit or contact service at CETAC and then follow the service bulletin. So I mentioned this on the slide as well. We have a service bulletin that's required for repairing kits that have caused a contamination of the rinse station, a technique for changing out the rinse station tubing, cleaning the rinse station, and then also cleaning the probe. And we found that this is successful in fixing the drip problem and it not coming back as a result. We've also introduced FEP-lined drain tubing, and these would be for particularly difficult applications such as DMSO, where Tygon isn't going to hold up very well. And in addition to that, we've introduced drip-resistant probes for particularly difficult applications. These would be recommended for situations where people have a sample matrix that's particularly oily, like sludge water or organic samples, where things are going to stick to the probe and contaminate it the same way that any other organic oil would contaminate the surface of the probe and cause dripping. So please contact CETAC service. We have solutions for this. And also on the website, we have materials and service bulletins for how to fix any problems that might be existing in the field now. So in addition to the hardware changes, we've also introduced firmware changes that cause the auto sampler to move in an intelligent motion around any of the samples and to avoid hovering over any sample that has not yet been analyzed, including the standard rack at the back of the auto sampler. So with the XYZ design of the CETAC auto samplers, it is possible to configure a sequence so that the samples are run in order rather than randomly or backwards across the auto sampler rack. And the result of this is that the probe would never travel over a sample that has yet to be analyzed. This way, even in the rare occurrence where a drip does come off of the probe, it falls into a location that hasn't yet been analyzed and doesn't affect the user's data. Other samples would be subsequent to ones that have already been run, and any potential contamination would be eliminated then. So other auto samplers on the market have a gantry style and a W axis that spins the probe in a circle above the samples. It is not possible for them to be configured to do this, and it's inevitable with any other auto sampler design that the probe will travel over a sample that has not been analyzed, and the potential for contamination then is present. Additionally, over the standard rack in the back, we've implemented a change to the firmware that's available that will allow the probe to avoid traveling over these samples as well. So I'll play a video. As you see, it comes out from the rinse station and then back to the sample at the back of the auto sampler without traveling on top of the ones in between. So the potential for contamination between different sample rack locations is also eliminated. So these firmware versions, along with the associated alignment software and associated configuration software, is all available on the CETAC website. If you hear thunder in the background, it's because we're experiencing a thunderstorm here in Omaha, so do forgive me for that. We do have, additionally, a series of enclosure options that will help eliminate contamination from your samples and from your analysis. The high-end version of this would be the ENC 560. So pictured here is the front view of the enclosure, as well as a diagram of the airflow. So the way this works is that there are holes cut in the base of the autosampler, which allow movement of the air through the HEPA filter in the back, over the samples, and then out through channels cut in the base of the enclosure through the vent. So what this does is create a very efficient airflow of material out of the enclosure interior, and then also all of the air that travels over the samples are filtered through the HEPA filtration system, and also eliminating the potential for any contamination that might come from the vent system itself. So the vent adapter, as you can see on the top of the autosampler, has a box around it, so that if any moisture or dust falls from the vent system itself, it falls into a containment area and does not have the potential to get into the sample area inside the autosampler. Other advantages of this model include the footprint. So it fits on top of the autosampler without causing any need for additional bench space. It allows unhindered access to the components at the back of the autosampler. It also has a reversible door design, so depending on the ICP model that you're using, you may want it to open from the left or from the right. It's very easy to switch the position of the door so that it opens either left or right. It's different from the old autosamplers that we had that opened upward, so the door would have to be balanced on the top. This one stays open and causes the user to have much easier access to the sample chamber. Other advantages include the design being completely free of metal components on the interior of the autosampler enclosure. So any fumes that are in there, even HF, it's not going to cause any potential contamination from metallic materials, screws or fittings or anything like that on the inside. So we've had a video taken as well. What we did is fill the chamber with dry ice and then apply the ventilation system in the back. And you can see through the back, this one has a clear acrylic material in the back. You can see that the fumes are being pulled up through that chimney, but also down. So as acid fumes are heavier than air, it simulates what would happen with the acid fumes inside an enclosure chamber. So this being in real time evacuates a very, very contaminated enclosure in less than 1 minute. The other advantages of this and this airflow, as you can see, is that the flow is away from the electronics of the autosampler. And the advantage of this is that as fumes do accumulate inside the chamber, they're pulled in a direction away from the components that are most vulnerable to corrosion. It causes the autosampler to last a much longer period of time and preserve the investment in the automation product. We also have a lower cost option available now. So with this, the chart shows compatibility with all of the standard autosamplers that CETAC manufactures, including legacy ones. So on the left, there's a picture of the ENC 280 DC, dust cover for abbreviation. So this fits both the legacy ASX 260 autosampler and the ASX 280. The advantage of this, of course, is bench space. We also have the larger end. So the ENC 860 DC is compatible with the legacy XLR8 and EXR8, as well as the replacement model that's come out in the last 2 years, the XLR8 60. So depending on the size of the autosampler, we have a dust cover design that's configured precisely for that bench space. Advantages of this particular design are listed here on my slide. The low cost avenue of this is probably most important, and that is applied not just to the transfer cost of the enclosure itself, but also the shipping. So with this particular model, the two sides fit into a box, and then the covers over it roll into another box, and it ships in a flat pack design. So the cost of delivery, the overall cost to the customer is very much reduced. Other advantages include the installation. It's very easy. It's a screenshot from our installation guide showing how it goes together. So the two slides on the top fit together, the green and the red lock together at the top, and then both of those slide up and down, giving easy access to the components of the autosampler. And then a variety of options in the holes listed on the two sides of the autosampler enclosure allow for a variety of different tubing configurations, as well as installation of the accessories. So, for example, if HEPA filtration is required or a positive airflow fan, it can be configured on both sides, or the 4-inch vent flange, which is included in the bill of materials for the enclosure. There's also a base that's required for situations where the autosampler might be sitting on an uneven surface or one that's not big enough to hold the entire 4 corners of the enclosure. So CETAC.com has all of these materials, as well as a variety of sales flyers and installation guides and spare parts catalogs for all of these. And with that, I will turn it over for questions.